Welcome to Pre-Cal. Today's lesson is Chapter 1, Lesson 1, called Functions. In this video, we're going to talk about Objective 1, which is to describe subsets of real numbers and the notation that we use for that. So, first off, I'm going to go over this chart, which hopefully y'all have seen before. Okay, and I like to start with the smallest set, which is why it's in here in the middle of inside all of the other ones. Okay, the first set of numbers that you have when you were really little and you learned how to count, the first set of numbers that you used were 1, 2, 3, 4, so forth and so on. That was denoted, those are called the natural numbers, sometimes the counting numbers, and it is denoted by the letter N. Then when you got a little bit older, you learned that number that represents you had no cookies on your plate. So that's the number 0 added to the set of natural numbers, and now we have whole numbers denoted by the letter W. And then when we get a little bit more, we learn about something called integers, which are your positive and negative whole numbers. And that is denoted with the letter Z, which I believe comes from a German word, but don't quote me on that. So all of those three right there, you're familiar with, okay? And all of those numbers are also known as rational numbers, okay? Denoted with the letter Q. I like to remember it because Q is a quotient, and a rational number is the answer to a quotient. So a rational number, y'all, is a fancy word. If you think of the first 5 letters, it's a ratio of 2 integers. So any number that can be written as a ratio of 2 integers is a rational number. So 2/3 becomes 0.6666 repeating. So any repeating decimal is also a rational number. -7/8 or 0.125, that is a terminating decimal. So all of those are examples of rational numbers. And every number that you've talked about so far is either rational or it's irrational. And irrational numbers are denoted with the letter I. An example of an irrational number involves square roots and pi or e. And then last but not least, so all of those rational and irrationals together make up our real numbers. And that is denoted with this letter R, or sometimes you'll see it as a, well, I don't know where it went. Okay, I'll write it. A cursive R, or you can do 2 letters and then write an R. Okay, so what do we have with those? First off, we have something called set builder notation. Okay, and set builder notation looks like this. Don't let that scare you. It's just a way of writing math and being very specific about what we have. So set builder notation always starts with this right here, which is your brace, that little curly thing that people have a hard time drawing. And then you have the variable x, and then you have a vertical line, which is read such that. So this says the set of numbers x such that, then you have some mathematical inequality statement, or you could list the numbers as you see right here. But whatever properties you're given to x in the middle, then you separate it with a comma and write x with this funny looking symbol, which looks like an E, and it stands for is an element of the given set of numbers, which in this case is Z, or our integers. Okay, so we're going to practice that. Describe the sets of numbers using set builder notation. So as I mentioned, every single one of these starts with the curly brace x such that. So x such that, and so now I have to think about a way to describe 1, 2, 3, 4, 5. There is more than one way to do it. I happen to think x is greater than 0. If you wanted to write x is greater than or equal to 1, that's fine. These numbers, 1, 2, 3, 4, 5, are just what we talked about before. X is an element of the natural numbers. So that is an acceptable way of doing it. If you wrote x is greater than or equal to 1, an element of the natural numbers, that works as well. Okay, next, x is less than or equal to -3. So again, I'm starting off with my curly brace, x such that. Okay, they've already described it with that sentence there, so I'm just going to write x is less than or equal to -3, comma, and they didn't give me any restrictions on those numbers less than -3, so then I just say it's an element of the reals, which are all the numbers that we have talked about so far. Okay, and last but not least, we have one that says all multiples of pi You might see this in your book a lot, especially when we talk about periodic functions with trig. So we start off again with x is an element of. Now we're going to say x is equal to multiples of pi. And how we say that is x equals pi n. Sometimes they use the letter k. And n is, if I want multiples of pi, I've got 1 pi, 2 pi, 3 pi, 4 pi, or negative pi, negative 2 pi. So n is still an element of our integers. So that's our set builder notation. The other kind of notation that you should have learned last year, talked about, is something called interval notation. So we go from an inequality right here to an interval, and we have bounded intervals or unbounded intervals. So if you look at this interval notation and that interval notation, the difference is all of these contain an infinity symbol and these do not, because infinity is unbounded. Okay, so you'll see we'll do some examples of those. But the thing that you have to remember is, when do I use a bracket and when do I use parentheses? So one way I like to remember it is, if my inequality statement has an equal sign, which is that straight line underneath my inequality symbol, then I'm going to have a straight line when I describe that number. So that's a bracket. Infinity, as we just said, is unbounded. You can't ever get there. You can't ever reach it. So it's always parentheses. The curve, think about that with the curve of your infinity symbol. Okay, so more importantly, how do you go between the inequality to the interval notation? I think it easiest if you'll think about a number line. So when I do these first ones, I'm going to graph them, so that if you have any kind of struggle or any confusion about it, hopefully you know how to graph these inequality statements, so therefore it makes it easy to put it into interval notation. So this first one says negative 8 is less than x is less than or equal to 16. So I'm going to put that on a number line, and I'm going to take, okay, and just to refresh real quick, okay, negative 8 has an open circle because there's no equal sign. 16 has a closed circle because it has an equal sign. So the two numbers that have the circles on them are going to be the parts of my interval. So I'm just going to label negative 8 comma 16. And then I have to think, do I need a parentheses or a bracket? Well, the negative 8 doesn't have an equal sign, so it's parentheses. The 16 does, so it's a bracket. And that's all it is. Okay, let's look at another one. I have x is less than or equal to 11. So I'm going to go over here. I'm going to put it on, and I said less than or equal to, y'all. Sorry, x is less than 11. So then I'm going to go to my number line, and we put an open circle on 11, and we shade to the left. And then I've got to remember, well, what number's all the way to the left on the number line? And I'm sure y'all know that that's negative infinity. So I'm going to have 11 is one of my endpoints, and negative infinity is going to be the other one. So I write those two with the comma. Negative infinity always has parentheses, and the 11 is an open circle. It does not have an equal sign, so it's going to be a parentheses, and that is not what came up. But I fixed that, so let me go fix it again, because it didn't like how I fixed it. Yeah, that's supposed to be parentheses. Okay. Now I have x less than or equal to negative 16, or x is greater than 5. So again, I'm going to put that on the number line. I'm going to graph it. Okay, so we plot negative 16 is equal to, so I have a closed circle. I always put 0 because people often forget where it is. But it doesn't have a circle on it, so it's not going to be used in my interval. So I got a circle on negative 16 closed because it's equal, a circle on 5 that's open because it's not equal to, and if it's less than negative 16, I'm going to the left, greater than 5, I'm going to the right. So I have an arrow on here, so I got to remember all the way to the left is negative infinity, all the way to the right is positive infinity. So the key, the difference here, y'all, is I'm actually going to have, because I have two pieces of my graph, I'm going to have two intervals. So I'm going to have negative 8 and negative 16 on one of them. And I'm going to have 5 and infinity, whatever that is, infinity on the other one. Negative infinity is always parentheses. Okay? Negative 16 is closed, so it's equal to, which means it's going to be a bracket. 5 is open, so it's going to be a parentheses. And we put those together with the mathematical symbol for OR, which is a U. Okay, so those are 3 examples for you. Now, one of the things, as I just pointed out, notice that my graph had 2 pieces, or my original problem had 2 pieces to it with an OR. That's a clue that I'm going to have 2 pieces here. This was 1 piece. This was 1 piece. I have 1 piece. I have 1 piece. So think about that. This answer will be 1 piece, and 2 pieces. So to start off with, I'm actually not. What I think you should do is pause the video, try to do these 3 on your own, and then come back and check yourself. Pause. You're back. Okay, so -4, y is between -4 and -1. So those are my 2 numbers that I'm going to use. There's an equal sign with the -4. There is a parentheses with -1 because it's not equal to. Okay, a is less than -3. Excuse me, a is greater than or equal to -3. So I need the numbers bigger than -3. So I'm going from -3 to infinity. It's equal to, so I have a bracket with -3, parentheses with my infinity symbol. Okay, x is greater than 9, which means 9 is the smaller number. If x is greater than, that means this part, this piece right here, y'all, if x is greater than 9, then 9, it goes from 9 to infinity. Now, the order doesn't matter so much, but I'm just going to put it on that side. So that's 9 to infinity. Then it says x is less than -2. So I'm going from negative infinity to -2. So I have those 2. Infinity always has parentheses. -2, neither one of these has an equal sign, so they're both going to have a bracket, and then they're going to have the U symbol for the OR. Okay, that is the end of this video. I hope you thought that was easy. If you have any questions, please don't hesitate to email me or come see me. Thank you so much.